All right, I'm going to talk about analyzing linear data today, and mainly just a straight line. We won't worry about curves or anything like that. But the vocab that we'll be talking about: best fit line, regression line. They both mean are interchangeable for the same thing. We'll talk about prediction equations for that line, scatter plots. We're going to talk about correlation coefficient, but we won't necessarily talk about how to get it. We'll talk about what it is, how to interpret it, things like that. And then we'll talk about domain and range. So domain are x values, range are the y values. So the horizontal axis here is x, vertical axis is y. But we talk about two different ways of naming them when we talk about scatter plots. Typically we like to call them independent variables or explanatory variables when we're talking domain or the horizontal axis. And when we're talking about range, we like to use dependent or the response variable. So those are all terms we'll use instead of just domain and range. And then we'll finish it out with, I'll show you how to plot these on two free software packages. There's lots and lots of them out there, but these two are the ones I use most often. So let's get started first by talking about what is a scatter plot. And so right here you can see a scatter plot, and it's got 572 points. I'll pull the site down so you can see it. It's www.bc.edu, and it's a correlation simulator. And what you have here, so you can adjust the number of points so you can get it down to just 100, couple cases if you want. And we have this correlation coefficient, which is also called an R value. And right now that R value is 0.98. And you look at how lined up these points are. We've got 44 cases. Here's some points. There's 39, 40.2. And what's kind of cool about this is, what does it look like when there's a zero correlation coefficient? And there's a zero correlation coefficient. If you notice, all the points don't line up at all. There just looks like random scatter. And what happens if we go negative? Let's go negative about halfway. Notice the points generally look like they're going down and to the right. Here's your x-axis. Again, this is your explanatory variable. Here's your y-axis. Again, that's the response variable. And as you go from left to right, if you have a negative correlation, if you take this all the way to -1, notice your correlation is a perfectly straight line. So there's no scatter at all when the correlation is -1. Same if you go to +1. Positive correlation means you have a positive slope, and it's going up and to the right. And so what's kind of cool is to play. There's several games online that you can play with this to guess the correlation. Like there's a 0.77 correlation, and so it's got some scatter, but you can see a linear trend to it. You can pull it back. Kind of the same. There's a negative 0.57. Random scatter, but you can see this nice pattern down and to the right. And so that's a scatter plot and what correlation coefficient is for the most part. -1 is a perfect line going down and to the right with a negative slope. +1 is a positive slope going up and to the right. But correlation coefficient is not slope. Be careful there. It is just a value that gives you approximately how linear it is and then what direction the slope is headed. So how can we graph these? Well, first off, what I'd like to use is Google Sheets. So if you go into your Google Drive and you add a sheet, that's the best, one of the best tools out there to do this. It's totally free, other than you got to create an account. And so what you do is you highlight your data. Notice I put in here price of a car in thousands of dollars, and that's the explanatory variable, the price of the car. So this 7.15 represents $7,150. 41.8 is the miles per gallon. So if you spend $7,000, this particular car, when you spent $7,000 on it, it was running right at 41.8 miles to the gallon. This was a $45,000 car approximately. It only was getting 13.3 miles per gallon. So let's see what that relationship looks like when you graph them together. And so what you do is you highlight all of it, including the price in thousands and miles per gallon. You go to Insert, you go to Chart, and it'll give you a chart that's not necessarily, I'm going to scroll up a little bit so you can see it. Gives you a chart, but it's not necessarily what we're looking for. And so if you look over here on the right, notice it says a line chart. What we want is a XY scatter. You know, they give you a suggestion. This one doesn't look too bad. There it is. Yep, it's a scatter chart. So they've kind of figured out what we're looking for there. Notice it put in the miles per gallon here, the price in thousands of dollars here. And if you look over here in the options, we can even come up with the equation and things like that. So to get the equation of that trend line, you go up here to Data and you got Customize. We'll hit Customize. We'll go to Series here. And if you look, you can see trend line on there. You can change a lot of other things, but we'll click trend line. And I'll pull this up so you can see what's going on. See if it'll let me do that. Whoop. Went the wrong way. There we go. So notice it says linear. We're going to stick with that, but you could change it. There's other types talk about in a later video. And then label, we'll go ahead and customize it, or use equation, excuse me. And notice the equation pops up. So it's negative 0.528x plus 35.8. So your y-intercept's 35.8. Your slope is negative 5.28. And then off to the side it says show r squared. So that's kind of the bad part here. It doesn't give you the correlation coefficient, but it does give you r squared. So you just have to take the square root of that value. R squared is 0.66. And so to find the r value, which would be the correlation coefficient, we'll go ahead and take the square root of 0.66. Hit equals, and we get a 0.81 correlation. So it's getting very close to 1. Now the other thing you have to look at is you have to look and see, oops, wrong graph here. You have to look and see, is it positive or negative? Because it won't tell you that. Well, since the slope is negative, it's going down and to the right, that means the r value, or the correlation coefficient, is also negative. So in this case, we have an r value of negative 0.81. So that's fairly good correlation. And I'm not going to ask you to formally, my students right now, we're just learning it for the first time. There's all this, we can formally mention it in terms of the response and explanatory variable, and we won't work with that statement right now, but there's a formal way of stating that so that with your problem. But for now, all I want you to do is 0.81, yeah, that's getting close to 1, so it's fairly linear. Alright, so that's using Excel, or not Excel, excuse me. That's using Google Sheets, which is similar to Excel, but free. The other method is Google, which I showed earlier. So in Google, not Google, GeoGebra. GeoGebra.org is the website you go to. You could go to Start Graphing, but we kind of know what we're looking for. So in the bottom of that, we have, you can see under the Classic Apps Spreadsheet, you just click on Spreadsheet, and this pops up. Now I already put the data in. It's the same data as we had before. So I didn't put the labels in. That's one thing about GeoGebra right now. I mean, that might change, as we're not too concerned with labels yet. But there's a lot more options we can do. And so you highlight the data just like in Excel. And we want to do a 2-variable regression analysis. So there's that regression word. So we'll go ahead and click that. And it'll generate a regression model. Might take just a second because my internet's running really slow. And here it is. It's pretty similar to what we had before. And that gives you the model, the scatter plot. And if you want the regression, whoops, dang it, I keep hitting the wrong button here. I'll pull down, and you look down here on the bottom under regression model. If you change that, you can change it to linear, and it gives you the equation. Y equals negative 0.53x plus 35.83. So there's another way of getting it. Now, correlation coefficient's a little tougher to find, and so what you have to do is plot this thing, or go into the algebra side of this thing. And so give me a second to find that. I'll say when you hit these 3 bars here, you go down and you pull up algebra. You can get rid of like the graphics one. That'll give you some more room. I'd leave the spreadsheet in place. And so when you get that, you'll notice over here you've got an input bar. And so we can input some stuff. But first what we got to do is make a list for our points. So I'm going to highlight all the data. And I'm going to create a list or a list of points, either one of them. And so I'll go ahead and create that. Notice the name of it's L1. I'll create that. There it is. And whoops, and hopefully it didn't, whoops. Yeah, my screen's flying around here. And so if you go to the bottom of that, we can input a value. And I'm just going to type in CORR, and notice it comes up. So you click on that, correlation coefficient. And you take out that list of points. And we're going to go L1. And it gives me a syntax. And I think it's, I need to do an L_1 for L1. So let me pull that over here. So let me get down here to it. There it is, correlation coefficient. And I'm going to put a little underscore. Let me get rid of this thing here. L_1. There we go. Now it looks like it needs to be capitalized, so let me capitalize it. Okay, L_, which I use a dash, that underscore, and then 1. Enter. There, it gave it to me. So negative 0.81. So it's a little tougher to find with GeoGebra. You got to kind of know what you're doing. That's why I always like, for finding correlation coefficient, you got to know a little bit on both ends. But those are 2 free methods for using this, for finding your scatter plot and your linear regression line. So hope that helped. See you next time.